Welcome back to Planet X News. It is April 12th, 2017. And once again, we are here with Chris Potter and our physicist. And today, ladies and gentlemen, we feel that we have some pretty groundbreaking information over the course of the last couple of days. All kinds of information has been coming in. We have some pretty spectacular photographs that were captured on the ISS earlier in the week. And now, once again, a photograph was shared with me yesterday, and the photograph was taken yesterday from the ISS, the International Space Station, clearly showing a very large, what seems to be a pinkish or reddish type of planet, or possibly this brown dwarf star. We also have the latest report from our physicist, and she was doing some calculations based on the things that were happening with the magnetosphere. And her calculations are pretty good. Now, it is putting this brown dwarf star, or this major object, very, very close to our planet, very close to the sun. And from what we've been reviewing over the past several hours, it looks like it's coming in rapidly. So we're going to go ahead and get directly into this information. Doctor, how are you today?
I'm fine, thank you, Scott. And how are you?
Oh, I'm doing pretty good. You know, besides everything that's going on in this world right now with the threat of war in the Middle East and nuclear war over there in Korea and everything else going on around the world. Yeah, I'm having a pretty good day. Chris, how about you, buddy? Christopher?
I'm doing well. I'm excited to look at lens flares in space.
Yeah,
talk about mathematical formulas that are just fantastic, right?
Yeah, ladies and gentlemen, what Chris is referring to is naturally any information that our physicist is coming out with. The trolling camps, the other faction, if that's what you want to call it, they are trying to debunk and disprove with dishonesty what is actually occurring. And basically, they're putting out a lot of false information. And for everyone that is subscribed to both of my channels and Chris's channel, well, the bottom line is the doctor has been putting forth a lot of her own individual time and effort into researching and investigating what is actually occurring. Now, ladies and gentlemen, here's the bottom line. And I've said this before, and I'm going to say it again. There is nobody else on this planet that is stepping up to the plate and putting themselves in the limelight and using their knowledge and their credentials to help us out. All we see out there are a bunch of other fakes that are trying to disprove what we are researching and investigating.
And they aren't putting forth, sorry to interrupt you, Scott, they're not putting forth any real math or any real math debunking. If you're going to debunk somebody's mathematical formula, give me the math.
Yeah, I would have to agree. You know, yesterday, one of these factions put out an absolutely ridiculous video. And during the video, they couldn't even pronounce their words correctly. And they were basically turning our doctor's words around and basically just outright lying. And then when it came to the math portion, well, once again, they just made absolutely ridiculous claims that the math was wrong, but yet they said, quote, well, you know what? We're just going to go ahead and skip over the math because it's wrong anyways. Anyhow, anywho, and anyway, that was absolutely ridiculous. And yes, ladies and gentlemen, the death threats keep coming in. Yesterday was a pretty bad day for me in general. I received, I don't even know how many countless death threats by text message, videos being made about me, talking about, well, I'm not even going to go into that. But I don't want to waste any more of your time. We're going to get directly into the information that came through with these photographs. And I'm going to go ahead and bring these photographs up. And this photograph, well, I have to share it first. Let me go back and try that again. And doctor, after I have this photograph up, go ahead and give your commentary.
Okay. Yes. Isn't that amazing?
Tell us why it's not a lens flare, because that's the first friggin' thing people are going to say. It's a lens flare in space.
Yes. Okay. So the brightest object in the image is the light source, and it looks kind of white. Okay. So that's the brightest thing, the thing that looks like the sun. And so if we were to have a lens flare, the brightest object would be the one to create the lens flare. Okay, that's what the lens in the camera would produce, a lens flare of. There would be an internal reflection inside the lens, and we'd get a lens flare of the brightest object, which is the object that we think of as the sun. And the sun in this image looks, maybe we could say pale yellow, but basically it's mainly white. So we would expect the lens flare of the sun to be white. And there's no way that the sun can produce a red lens flare, because the sun is not emitting red light, it's emitting white light, or sort of pale yellow light. Mm-hmm. And what we see there at 3 o'clock is a mainly red object. And you can see that its shape is also very different from the sun. The sun has all kinds of beams coming out from it, or perhaps coming into it. And this object does not have that shape at all. And if it was a lens flare of the sun, then it would have a similar shape, because it would just be a secondary image of the object, which would be the sun. So there's no way that this red object can be a lens flare. It has to be a real object, and it has to either be emitting mainly red light or reflecting red light. If it's reflecting red light and it's a planet, then we'd suppose there's a source of red light around, but it's not the sun. The sun is not emitting red light. So there we are, and it's been circled by somebody, obviously. It's obvious there's something there. Also, notice this object is more in focus than the sun itself. The sun looks very much out of focus, except for the beams coming out of it. So again, how can you have a lens flare that is more in focus than the main image, the primary image? It's not possible.
Let me ask you another question.
Yes.
We're obviously using similar lenses on Earth. There's probably nothing different between the lenses that we use on Earth to take pictures where we get lens flares and the supposed lens flares that are on pictures from the ISS feed, because the camera lens itself is probably not much different than a regular high-grade lens in a telescope or camera, whatever. So along those lines, I was thinking it's possible because of a lens or light anomaly or camera aberration that, well, gosh, that would explain away the quote-unquote lens flare action. However, it doesn't look like we can explain it away that easily this time around.
No, not at all, because, I mean, whatever lens we have in front of this camera, it would affect the main object as well as the lens flare the same way. So the only way you could have a red lens flare is if the main brightest object in the image is red as well. They have to look similar, not the same size, but they have to have similar shapes, and they have to have similar colors. I mean, they could, obviously the brighter one is always the main image, and the less bright one is the lens flare. But here, there's no connection between the two. They have different shapes and they have different colors. So one cannot be a lens flare of the other. They have to be separate objects.
That's a good explanation. I've seen lots of two sun or lens flare pictures where at first I was completely duped that, oh, it's two suns. After a little bit of investigation on my own, a year or so into my YouTube channel, yeah, okay, I am. I'm looking at lens flares. They're pretty obvious at that point. But you made one point that was clear to me right now, is that those flares are typically the exact same shape or the same color. And that I don't see in this picture. And I don't think it really, and for the listener or viewer, it doesn't, means nothing that it's in space, quote unquote, or the ISS feed. That really doesn't matter, because it's just a camera like we would use on Earth. Maybe there's a couple little things out in space we're not too familiar with that might cause a different lighting or shadowing or whatever other type of aberrations maybe we're not familiar with. But in this case, with the standard explanation that you've given countless times, unfortunately, you needed to about lens flares. It wouldn't. It doesn't jive. It's not the same. There's obviously something there creating a red what looks like a green stripe through it.
Yeah,
I've been real hesitant.
like a yellow.
I've been real hesitant to say that, hey, guys, that's not a lens flare. But I'm going to have to say I don't think it's a lens flare either. I think it is the flying cheese sandwich.
I want to interrupt here very, very quickly. Ladies and gentlemen, you notice this this pixelization around the red circle that was drawn on the photograph just to encircle it. And that is the reason why it is pixelated. I also want to mention something right now before things go a little haywire. We already have trolls in the live chat.
Of course.
They're claiming that this picture was stolen from them. Okay, well, listen, ladies and gentlemen, and to all of the trolls out there, if you by chance don't know anything about copyright law, federal copyright law, well, this is the International Space Station. This is a public feed, and you do not have the legal right to claim any photographs, whether you have taken them or not. This belongs to the federal government, and it cannot be copywritten by anyone. We've already gone over that information back in October, November, and December when troll factions were trying to claim government copywritten video and photographs from the International Space Station, from SOHO, LASCO, SDO, SETI, and you name it.
Wow.
So please don't even go there. Just get out of my live feed. Go find a job. Go crawl under the rock where you just popped up from. This photograph was sent to me by one of my good friends, and he captured this photograph. He encircled it, and he sent it to me in my Facebook inbox. Okay,
so they were just looking at the ISS feed, saw it, took a snapshot, sent it to you. Boom.
Very simple.
Yeah, that's BS. Yeah, so whatever. Yeah, they need to go away. Go ahead and continue, Scott. You're the man.
Yeah, so getting into this federal copyright situation that these trolls try to use right now, they're trying to get channels kicked off of YouTube very rapidly by filing false claims and flagging YouTube videos and YouTube channels. 48 hours ago, one of my other channels, which strictly deals with Earth weather and space weather, I haven't uploaded a video in weeks onto that channel. I got an email from YouTube stating that they terminated my YouTube channel. It's called Earthwatch and Space Weather. Well, the email stated that it was taken down for gross violations concerning spam and scam.
Oh,
well, that was absolutely ridiculous. So I went ahead and I immediately appealed their decision. And when an actual human being took a look at the information, within 15 minutes, I received an email back from YouTube apologizing for terminating my channel. It was reinstated in 30 minutes, and that was that. So ladies and gentlemen, YouTube uses bot programming, and apparently these trolls think that they are actually onto something to bring your YouTube channel down. But through a course of several emails and communication with YouTube yesterday and first thing this morning, they are fully aware of the situation, and they are also fully aware of the YouTube channels that are trying to use YouTube's own policies and procedures to do these types of things. Now that we've got that out of the way, Doctor, you could go ahead on with your commentary on what you're seeing.
Okay, so there's the red object, but it's not the only red that we see. Behind the sun, there's a bit of red as well, as if there was another red object or light-emitting light source behind the sun.
Yes.
Because you see above the sun, you see that around the edge, it looks red.
Yes, like something's behind it.
A lot of, yeah, like something's behind the sun. So that may actually be the star that's emitting the red light, and that planet may be reflecting some of that light. That's why it looks so red.
Well,
And
why is it not like a flare or like a corona or like a, what's the word? You know, okay, I don't know the right
an
technical
ejection?
terms, and I'm not an
Plasma-
optical guy. Well,
Yes.
sorry to interrupt you. No, what I mean is the blurry effect we see of the so-called sun and the lens, because it doesn't look really blurry to you. It's not,
Yes.
the object on the right is more clear than the supposed sun on the left. And I've got to make another point and kind of segue this in there. When I first met you, I had showed you, or I had put out pictures from the ISS that they don't look right. And
That's right.
you got back to me and go, I don't know how anybody can believe this is the sun. It looks like it's a containment systems and there's lasers, and the lasers are coming out. They're breaking out of the
I did.
Right? So, and honestly, folks, any pictures that you see of the ISS, and then you see pictures of the sun on Earth, it doesn't look the same. So I've always been like, well, oh, maybe the cameras are different or something out there, you know? Or, you know, I didn't know what it was. But anyway, I want to mention that, and I just want to mention the fact that the sun is so overwhelming and almost blurry looking. And yes, on Earth, that will happen because, you know, it's a bright object. You know, you're told in school, you're not supposed to look at the sun. You're going to burn your eyes off, you know, your cornea.
Yes.
There's a lot of wisdom to that because you can see that it's an overpowering light source, and the clarity that's not there. Can you speak to any of what I'm maybe referring to?
Yes. Okay. In the previous image, we could actually see a beam coming from the bottom towards the sun, and it was in focus. It was at 6 o'clock. Look how sharp that beam is.
Okay,
that is
on cameras on Earth too, though, where it's a crappy camera or it's a bad CMOS in the camera.
No,
well,
I think it does.
Here's something that I want to point out. When we're looking at this this photograph right now of the sun, and this photograph in general, this is being taken through some very thick glass on the International Space Station. However, the object that is circled is in no way, shape, or form a lens flare. But
it's not blurry.
Yeah, what I want to point out is the perfect symmetry of the rays of the sun. There is absolutely no way in nature that the sun's rays can be perfectly spaced out as what you're looking at on your screen right now.
So
Absolutely.
That is absolutely 100% impossible. That has to be an artificial. Yeah, that has to be an artificial light source. I mean, it looks like a spoked rim on a car. It's perfect.
It does not look right. So what was the doctor mentioning about the long straight line?
This ray right here, this beam right here.
Yeah. Yes. So what that looks like to me is, it could be two things. It could be light rays coming out of it, but I think the more logical thing is what this object is a reflector, and laser beams are being emitted from outside the region of the reflector towards the reflector, and what we're seeing is the reflected light, which looks like the sun. That's why there are these beams. It's a hexagonal symmetry. So there are 6 of them coming in towards the reflector. And what we're seeing in the middle is the reflector, and the light is being reflected off. And then there's probably another lens in front of that to make sure that it looks diffuse, so we don't realize what it actually is. So that I think that could be what it is. And you know, in the old images, we always saw a circle around it.
Yeah.
So that circle could have been the actual size of the reflector, and in the middle is where the beams intersect, and then the light reflects back towards the camera. But that beam at the bottom, that's the one that's coming in from the place where the camera is. That's why it looks so sharp. And then there are obviously other ones coming from 5 other directions. That's what it looks like to me. So definitely, I think Scott is right. There is no way the sun would have this hexagonal symmetry with 6 beams coming. Okay, you can even think of it coming out or coming in, but 6 beams like that is not.
Yeah, I mean, if you look at the distance, if you follow my cursor, look at the distance between this point and this point, this point and this point. I mean, this is basic. this is basic. What would you call that?
Yes.
Geography? No, not geography.
Yeah, geometry.
Geometry, yes.
Yes.
I couldn't spit that one out between geology and geography. But
Yes.
yeah, I mean, that looks like a spokes on a wheel, perfectly separated with the same distance between all of them. So
That's right.
you know, even taking into consideration that the photographs are taken through very thick glass, you would still not end up with this type of object. I mean, you can see in this photograph, it's even better. I was trying to play around a little bit with the you know, the coloring so we can bring it out more.
Yes.
But you can see this object, it has stripes on it.
Uh-huh.
And again,
That's right.
this goes right back to that very large striped object that we looked at the other day, the photograph from the ISS, the photograph from my subscriber from Europe that took that telescopic photograph, the photographs that coming in from Bondi Beach that I captured, and also Jeff P. captured. Ladies and gentlemen, we're getting a little bit into the situation where these just are not occurrences that we're making up. I mean, what are the odds of coming up with this type of object going all the way back September, October, November, December, January, February, March, and now April of 2017? Wow, that's a pretty damn big coincidence, don't you think? Don't you think?
The fact that it's striped like friggin' Jupiter is seriously concerning, and I've really not wanted to talk about it. I have been so hesitant to make any mention of your pictures on Bondi Beach, this picture here, a previous picture that I have in my picture videos that I'd sent out that you shared with me from one of your subscribers that looks like, what was it on the left? A light white object, and on the right, a huge, perfect, circular, friggin' Jupiter looking thing. And I know you know exactly what I'm talking about. Are you we also, but yeah, is this the, and yeah, let me just mention, that's the weird lightning orb video. Is that what it is?
Yes. Now that
video, you go, bro.
That video was captured in New Jersey, April 4th, 2017. I got an email on it early yesterday, and I didn't get to the email until much, much later in the afternoon. And I'm assuming it came directly from the person that actually took the video. And what it was is, it just, the video starts out with this blinking object, very, very rapidly blinking. And I did my best because the video was taken on a cell phone. You can clearly see that the imaging wasn't that great. However, whenever I was able to take some still photographs of this and slow it down, which was very, very hard to do because this object was either rotating or blinking, or these plasma bursts or electricity, lightning bolts, whatever you want to call it. It was happening so fast that it's almost impossible to capture it frame by frame. So it took me hours to get these critical frames that we're looking at right now.
Oh, that's what you did. Because if you look at the video, it's a great video. It's a little bit blurry.
Yeah.
But, okay, and if you look at it from a lightning perspective, I do not remember lightning going off from the same exact point for like 5 minutes. You see what I mean? Like, lightning usually is like all over the sky, right? He's in all over different places. But this looks like a friggin' ball that's spewing lightning, and he's just sitting there hanging out. I know I'm really animated and loud right now because it's freaking me out, man. It's a video I haven't wanted to speak to, so I'm glad that you have some still frames of it, because what you just had up almost looks like a hand with someone holding a ball, a white ball.
Well, in the actual video, there is some cloud cover. And looking at this video, I inverted the same photograph. And if you follow my cursor to the left of the screen, you will see some of the thicker cloud cover, which was actually closer. And then in behind, there were some faint clouds, but there was a lot of cloud cover. Now, I've seen heat lightning many, many times. All of us have seen heat lightning.
Thank you. Okay, sorry to interrupt you. I really had to. I was looking for the term. Go ahead.
Yeah, this is an absolutely no way in hell was that any form of heat lightning. Heat lightning just does not react like that in the sky. I looked it up. I watched some videos of heat lightning. There is absolutely nothing to compare what was seen in New Jersey on April 4th. Now, this is an inverted photograph. You can clearly see that in this inverted photograph, in the exposure, you're looking at either a massive heat source or a very, a very big round object that was giving off all of that plasma discharge or electrical discharge.
Yes. Well, I find these very exciting, actually, because this is, to me, the classic brown dwarf. This is a highly magnetic object with now a high electric field, and it's got a gas cloud around it, and it's having very dramatic plasma discharges from its core and out through the cloud. This is exactly what I would expect a brown dwarf star to look like. So to me, this is very exciting, Scott.
Yeah, I mean, I'm going to go ahead and I'm just going to play with the coloring so everyone can actually see what we were looking at earlier whenever we were examining these photographs. Okay.
And also these objects, when they come into the solar system, usually do not emit any visible light. And obviously the core of the star, or it could be the cloud, because there's usually a bit of cloud enveloping the star, very close to the star. So this cloud obviously still has its cloud, so it doesn't have fusion reactions yet, but it has a lot of energy. We can see that from the plasma discharges that are happening. And it could be the cloud that is close around the core of the object is emitting light, and these discharges are going out throughout the cloud and creating these effects. It looks very interesting. It's fascinating to me, actually, to see it. So that black there is the core of the object.
Yeah, it is quite fascinating. And, you know, at the same time, it's a little, it's definitely, it's definitely alarming, you know, to say the least, that, you know, looking at this object, well, I couldn't even imagine being the person who videotaped this. You know, I just, I would have been in complete awe standing there, you know, videotaping this and trying to keep a steady hand at what you were actually looking at. And the pictures, like I said, it was very, very rapid, what was occurring in the sky. And the person did the best they could to capture what they did. And I'm assuming that this small object up here, that should be Jupiter in the sky. Because, I mean, Jupiter is visible in the nighttime sky pretty much from dusk till dawn right now. So that would be my only guess, unless this object has a little partner.
Yes. Well, there's always that possibility, but it could be a binary system. They often come as binaries. But the fact that this person could film this object so easily and it's so clear means it's very close to the Earth. That's what is very interesting about it as well.
Can we
look how big it is?
Watch a clip of that video a little, Scott?
Yeah, absolutely. I'll have to
compare it with your stills.
Yeah, I'll have to get that pulled up. Give me a minute.
Thank you. What I was doing on my PC there for a second, I was looking at, I was just comparing really simple pictures between the ISS from that camera and then from folks' cameras on the Earth, and they are distinctly different. And I'm not going to believe, or I'm not going to buy into the fact that, oh, it's the type of camera lens, and oh, it's something in space that's causing a significant looking difference between our sun and some weird looking friggin' thing in space that has spokes. It doesn't look normal. It looks like lasers breaking out of a containment. It's sickening to me that we are being lied to about something. I mean, that's what we got into the whole sun simulator. Not to break away for a second, but it looks like it's some type of device that reflects the sun or blocks it. Like some type of shield. It's so obvious. Anyway.
That's right. Yeah, I think you're right, Chris, because what they do is they use these devices and they place them in the right position, so whatever object is behind it is not obvious to us. But the thing is, they don't work perfectly, so that's why we usually see like a red light emitting object behind it, especially nowadays. Obviously, these objects are getting brighter and it's easier to see them.
Do you see my screen now?
Okay.
Do you see my screen now?
Yes, I do.
Oh,
yes,
okay,
there
so
it is. I remember seeing that.
Of what I was. So here's a good picture of the sun on Earth, okay? And we'll just say it's the camera and the atmosphere, and that's why I don't get pictures of the sun looking like that, right? Come on.
Yeah,
that is not normal. What in the crap is
not.
this thing? That just, sorry, I'm
You're
going
right,
nuts
it's not
about it.
normal.
It does not look right. That's the sun. That's something.
That's right. It's
Awesome.
a device. It's obvious that it's a device.
Has to be.
It's symmetrical. You can see the 4 laser beams coming in or out of it. 4 main ones and then 2 other ones offset from that. It's like it's 4 strong ones and 4 less strong ones offset by a certain angle. But the symmetry tells you it cannot be a natural object. It's got to be a device.
And we understand that there's not water in space. There's not supposed to be any water. So it shouldn't be making hexagonal lens flares.
That's right, it shouldn't.
Moisture. All right. I just want to that. Thank you. How do I stop?
Of course, if there's a hexagonal lens flare, there has to be a hexagonal object, bright object causing it.
How do I turn off?
No, I think it's off.
Oh, it is. Okay, I'll let Scott take it back. Yeah, I couldn't turn it off for some reason.
Yeah, I don't know. Scott is still looking for the video.
Oh, I have the video. I have it ready to...
Yeah, go ahead. Can you take the screen back from me? My computer won't give me the ability to stop.
Yep, I got it.
Okay, great. Thank you. Still learning how these little live hangouts work. I'm not used to them. Thanks.
Yeah, we'll go ahead and pull this up real quick.
Thank you for your comments, Doctor. I don't mean to interrupt either of you. Since it's the 3 of us, we kind of have to interject when we can and try to keep a flowing conversation. I appreciate both of your patience with me. Thank you.
That's fine, Chris. I like your questions. And it's nice to be reminded of what happened right at the beginning when we met and we started talking about these things.
Yeah, it changed my life. Yeah, look at that.
Wow. Yes, it's fascinating. It's
one of the freakiest videos I've ever seen.
It's amazing. What amazes me the most is how close it is and how it looks exactly like I've been saying a brown dwarf star should be. And how I realized it should be doing that was I was looking at SETI images and I realized that these objects must have clouds around them and it's amazing.
Did you see that big ripple?
That was part of the my video effect.
Okay. It's okay. I was be like, whoa, dude, what was that? All right, so you put you're just looking at a clip. Now, is it a repeat right now, Scott? Is it a loop or is it the entire video that you're showing?
No, it's my video that I
put. Gotcha. Okay, sorry to interrupt you. And then the ripple was from the effect from Filmora.
Yeah.
Filmora too. Okay, gotcha. Just want to make sure we weren't looking at something crazy because on another note, Mike from around the world and myself recently have pictures of rainbows around the friggin' sun. And they're becoming more and more prominent, more and more clear. And so for a second, that's what I thought it was. So, okay, never mind.
Okay. Yeah, so what you're seeing there is very fast plasma. It discharges across the cloud from the center of the star. And it's just amazing to watch this. It's just... I never...
Go ahead, sorry.
I never thought I would see something like that because in the SETI images, you see a little something here and a little something there because, you only get images every 12 minutes. To actually see footage of an active brown dwarf star, well, it's not emitting light from the core yet. I think this is the cloud itself, the cloud right around the core and the cloud around it. They interchanging charge So we see these lightning type discharges across the cloud. It's absolutely amazing. You know, we would never get footage like this from SETI. You only get an image every 12 minutes, say. So you have to figure out what's happening from those. So footage like this is absolutely amazing because it's continuous. You see the actual object, the energy it has, and how it's behaving. It's very, very interesting.
I just have never seen lightning or heat lightning or any other natural phenomenon behave that way.
No, this is definitely not on Earth. This is in outer space. This thing. This is no way that the Earth's atmosphere would do something like this. You actually see that the lightning is emanating from the center of this object.
Yeah.
And it doesn't go very far. It stays contained to the cloud around the object, and that's obvious in the video.
That was very apparent.
So it's not.
It doesn't go anywhere. It
Yes,
stays. Yeah.
That's right.
And I don't remember lightning behaving that way. And again, the new term that lightning I've never even heard of. And I just don't. No, I've seen ball lightning. I saw a famous ball lightning little dude rolling across the hayfield in Russia. That was really cool.
Yes.
And he's a ball. He's a ball of lightning, right? He's not an alien or anything weird. But I'd never seen.
Yeah, I mean
so if it was something brand new, great. Hey, we're all going to learn together. But I just have a strong feeling it's not anything we've seen before, and we should probably pay attention. Now, it's too bad. So the cell phone video itself, was this the highest quality we were able to obtain?
Yeah, it was taken on a cell phone, and plus at night.
Yeah, the night part doesn't help it either.
Yeah.
No problem.
The night part is also interesting. It means this object was on the outside of Earth's orbit because it's in the night sky. It's in the night sky. So when we look from Earth and we see the night, we're looking away from the sun. We're looking at the outside of Earth orbit. So that's where Mars and Jupiter are, where their orbits are. It's outside. But if we look at an object that is close to the sun, that's on the sun side of the Earth, that's an object in the inner solar system.
Okay.
Okay. Basically, we're looking into the inner side of the Earth's orbit. So it's between the sun and Earth's orbit. So if this object was, if it was daylight, I would say this is an object between the sun and the Earth. But because it's at night, it's an object further away than further away from the Earth, on the outside, so further from the sun. I mean, not further from the sun, further outside of Earth orbit, so between Earth's orbit and Mars orbit, say, for instance. This object seems quite close to the Earth. It looks large. Remember, brown dwarf stars are not actually that large. They're not supposed to be large. They're supposed to be smaller, quite a lot smaller than the sun, than normal stars, and some may even be the size of the Earth. So for an object that is not that big to look that big and be so clear in the sky, it has to be quite close to the Earth.
You know, I was just trying to stop the video right at this point, and it's so very hard because this is moving so very fast. But if you follow my cursor, there was the outline of this object that I saw, only for a brief, a few seconds. But again, this would be impossible for nature to produce a perfect sphere of any kind.
That's right.
I don't. That's right. You know what I mean? I'm hoping that everybody can see it.
Yeah.
Oh yeah,
I can see it.
Yep.
Yes. Okay, so I just want to mention that a plasma discharge and a lightning discharge are basically very similar. So what we have on Earth as plasma discharges is what we call lightning. And they thin lines of heated air that starts conducting because of a large potential difference. So here in this cloud, we have that. That's why I called it lightning as well. It's a plasma discharge, okay, which can be thought of as lightning, but it's not the same type of lightning we have on Earth. You see that these discharges are thick, which means there's large areas where electricity and current is being conducted across the cloud. So there's a very large plasma potential difference between the core of the object and the outside of the cloud. And so you see very large, and it's happening very fast. So this object is very energetic, let's say, and it's quickly trying to equalize the potential between the center and the outside of the cloud. You see very large plasma discharges going on across this cloud, very large. And what we saw from the brown dwarf in the 2007 images is that the brown dwarf has basically two levels of cloud. It's got a cloud that envelops the core of the object, and it's probably a thin layer that stays close to the object. And that was the layer that was emitting light initially in the February 2007 images. And it was emitting light from one side of that cloud, part of the cloud that's very close and surrounding the core of the star. And then there's a cloud that goes further out, and it's more diffuse. So what we're probably seeing here is the spherical part is the cloud that closely envelops the object. And then the plasma discharges are from that part of the cloud to the cloud that is more diffuse, and it's in a more of a chaotic shape. It's not very spherical like the inner cloud. Sometimes that cloud forms a disk as well. And the other times, when the star has enough energy, it starts ejecting plasma from one point across its surface. And there you are. You see, it looks like a hole in the cloud. It punches a hole through that cloud that closely envelops the object. So it looks like a circular object with a hole in it.
Like the Death Star.
So that, yeah, that's right. Yes, and that's what it looks like there. You see, it looks like there's a hole in that object. So that would be like the hole in the cloud that closely envelops the star. So it means that it may have started emitting a plasma discharge now and then from its surface. And that's the first step that it goes through when it starts being able to have fusion reactions and plasma discharges from the surface. And eventually it has plasma discharges from everywhere around. So it blows holes through. It burns right through the cloud, and and then it will turn into just a small star that starts emitting light and so on. So we can see at what stage this brown dwarf is by looking at it and seeing what it's doing. It may have started emitting a little bit of light, and if we see a hole in the cloud, it may be having one plasma discharge from its surface. But obviously the cloud is very active, so it's gained a lot of potential energy already from being in the solar system. That's what I see here, and it's fascinating. I'm amazed at what I'm seeing here.
Hey, thanks, Scott, for showing that. I really appreciate it.
Yeah, no problem. It's
extremely hesitant to talk about it.
To capture it. You know, it's very hard to capture it, and it's in these using the YouTube video itself.
Sure. But that's okay. Yes. I think we made the point. Good job.
Yes.
What other goodies are we going to look at?
Well, we are definitely going to go over the last report that the doctor put forth, the one that me and you were talking about yesterday, and we were just waiting to get her on board. And I'm going to go ahead and share that because we can get directly right into that, because that was just that was a breathtaking report on, trying to calculate the distance of at least one of these objects. So I'll go ahead and get that screen share moving forward here.
Yeah, this is the object that is outside of Earth's orbit. It may actually be the same one that we saw in that footage, because that one was outside of the Earth's orbit. And this one is the one that has a very high magnetic field. And I think it may be the one that's causing the magnetopause reversals that we saw in 2016. And now we had another one in October. I think I put in the wrong date there. I should have said March 14th, 2017, right at the beginning of the second paragraph. So there were magnetopause reversals on April 23rd of 2016 and October 14th, 2016. And then we had the magnetopause a collapse in March 14th, 2017. Okay, so what the mistake that I made there, I said 2017, I should have said 2016 there. So I made a mistake there.
Right there.
So yes. So what I did in October of 2016, I used those two magnetopause reversals that happened in 2016, and I calculated from that where if it was the same object causing the two, and we see the one that happened in October of 2016 there in that image. So I used those two to calculate the distance this object would be. And I found it was 6.9 AU, which is between Jupiter and Saturn. So that's the distance that I got from using those two magnetopause reversals. So now, because there was the magnetopause collapse, which was even more dramatic than the magnetopause reversal of October of 2016, which we see here, then I recalculated to find out where, if it is the same object, where it would be. So, and then what you see there in the image is, the arrows show both the magnitude and the direction of the solar wind. And the sun is to the right of Earth, so the little object there is the Earth, and the sun is to the right, so the solar wind should be coming from the sun, and all the arrows should be pointing to the left. We have that magnetopause reversal. You see we get a strong wind from the left, because all the little black arrows are now pointing towards where the sun is. And you see they're quite long arrows, so that shows that it's quite a strong solar wind because it's got quite a high velocity. So that's what happened then. So that's the magnetopause reversal, when the solar wind velocity reverses direction. And the only way that can happen is if you have another solar wind coming from the left. And another solar wind means another star on the left of Earth. So that's the magnetopause reversal. And there, it's actually from your video, Scott, and that's the magnetopause collapse that happened on March 14th, 2017, where the magnetosphere just collapsed and the Earth was left defenseless, and the radiation went right into the Earth. We had quite a long talk about that.
Yeah, that was a very trying situation there, because, ladies and gentlemen, that was the part that NASA took down the information approximately 4 hours. The Higher Truth Channel and BP Earthwatch, and my buddy Pete over there in the UK, he was actually able to capture all of this. I think that he's the only one on the face of this earth besides NASA that was able to capture this imagery before they replaced it with what we would look at as just something normal, when in fact we had a complete collapse of our magnetosphere. It just completely collapsed. What we think is approximately 4, maybe 5 or 6 hours. We really don't know, because they skewed the information and they hid it from us. But luckily, Pete was able to capture this information as it happened, and he was able to record it. So that was a big plus on our end.
Yes.
So I haven't put out yet. This is the one that I was going to put out and we're discussing today. Gotcha. Sorry to interrupt. I was making, because I'm like, hey, this is a cool presentation. I didn't get this one. What's up?
Yeah, now you don't have to do it. You can just upload the video.
Yeah, there you go. Perfect. Yes. Yeah. Go for it.
This is this part of your report, Doctor. This is what I found, very, very intriguing, also very alarming, because this is where we're getting into the calculations of possibly the distance where at least one of these objects is from the sun as we speak. And it's very, very close. Now, even though we're talking about, about 178 million miles from the sun, plus maybe another 93 million miles from the sun to the Earth. But when you're dealing in space distances, ladies and gentlemen, these aren't very vast distances. These are actually pretty close. But I'll go ahead and turn this over to you, and you could go ahead and explain what we're looking at.
Okay, so what I said there was, for an object to cause this kind of magnetosphere collapse, it's got to be highly magnetic. And what we could possibly be happening here is a particle flux transfer between the sun and the star, and the Earth is possibly getting in the way or is aligned with it. Either way, it can cause the Earth to feel the particle flux from the other star, and it will feel like another solar wind from the other star. So it would take a very highly magnetic object to cause this kind of very strong solar wind to the point that the Earth's magnetosphere collapses. So then I go into explaining that it perhaps an iron core brown dwarf star, which would be denser, but it would have a much higher magnetic field, because the iron is what's called a ferromagnetic material, and it's very easy to magnetize by aligning the spins of the electrons. So the iron core would highly increase the magnetic field, or whatever magnetic field this object had, or the star had initially. So and so I calculate, obviously I could tell before that it was an object that had to be outside of the Earth's orbit. And then what I do is I calculate the time difference between the magneto pause reversal of October 14th, 2016, and the magnetosphere collapse on March 14th, 2017, and that's 151 days. So if the object is on the outside of Earth's orbit, which would make sense, that's why we would then have a solar wind coming from the opposite direction to the sun solar wind. So the sun solar wind would come in towards the Earth that we see there, and I call that Earth's position on March 14th, 2017. And that's when the magnetosphere collapses completely. So that's stronger than what we observed on October 14th. So I put the sun on October 14th, 2016 in alignment with the object, just in alignment. And its position on March 14th, 2017 is between the two stars. So that would have a stronger effect. Right, so there we actually see from the solar system scope what the position of the object would be. So the arrow points outwards, and you see the constellations there. It would mean it would be between Leo and Virgo. So looking outwards from the sun through the Earth, the arrow points through the direction, and that would be between Virgo and Leo. That's where that object would have been then. So, all right, so then, yes.
Let me just interrupt for just, so we're possibly and definitely talking about more than one object, because the object you're referring to now would be behind the Earth, but we also have another object behind the sun.
That's right. We actually have several objects around the sun. It's more than one. You know, sometimes in the SETI images, I mean, one of them we talked about, there was Venus and there was a Jupiter, and both of them were having plasma discharges. I don't know if you remember that.
Oh, yes.
So both of them had to be stars, and they had to be close to the sun. And sometimes we see also Venus, they use the name Venus to label these objects, but then Venus is having plasma discharges, so obviously it's got to be a star, it cannot be a planet. And sometimes we have Venus having discharges, and then we see plasma discharges coming off the edge of the image. So there's definitely more than one of these objects around the sun, and most of these objects have been there for a while, so they've absorbed enough energy from the sun to have started having plasma discharges from their surface. In other words, they're probably having fusion reactions, they're burning fuel already, and they're emitting light. And some of these objects will be, they're not as bright as the sun. They probably start out emitting red light. And I think I wrote one that Chris did recently, where I put together the color that the stars are emitting with the clouds we are seeing on Earth that are obviously reflecting these kinds of light.
The different
magenta,
colored light in the clouds, the different colored clouds, etc. Yes, you absolutely mentioned that. Mm-hmm. Can you explain?
So these are.
Oh, go ahead. You keep going, and I'll ask you a question. Go ahead.
No, go ahead, Chris.
Oh, I was just going to say we really have to deal with another elephant in the room, which is why or how can we explain or not explain, whatever, if planets have plasma discharges? Do they?
Okay,
Do planets have plasma discharges? And if they don't,
well,
yeah, anyway, can you speak to that? Because I would assume somebody's going to mention, hey, no, you know, planets do this because of whatever.
Yeah, well, planets are electrified objects as well. Okay. It's possible to get a type of lightning connection between, say, a star and a planet. Mm-hmm. Not so much the planets from planet to planet, because the stars are the ones that are positively charged. And we've seen that the sun had these lightning bolt discharges that were going out. So it's possible that a star can interact with a planet like that.
Okay.
But I mean, we've had our planets, we've been observing our planets in the solar system for many years. We've never seen plasma discharges coming off any of the planets. It's not normal.
I don't
What's
remember
happening
seeing that. I didn't remember seeing a planet having basically a CME.
Yes.
For all intents and purposes.
No, a CME, I mean, what I'm talking about is like a lightning bolt coming from, say, the sun and impacting a planet. That is possible. But a CME coming off a planet is completely impossible, because a planet does not have hot plasma. We can have a plasma discharge like we do lightning on Earth, and that's usually because of the solar wind coming in and ionizing our atmosphere. And then there's a high potential difference between the ionosphere and the surface of our planet. And so then we get lightning across, and these are thin bolts of discharge that we call it lightning, and they thin, and we can have that, and we can have we don't usually have the planets interacting with each other this way, because they all get ionized by the same solar wind. So they all get hit by the same potential from the sun. So they have basically all the planets end up with the same potential, so they don't interact with each other.
So didn't you mention that planets are negatively charged? You said the stars are positively charged and planets are negatively charged. Okay, I want to make sure we emphasize that too. Thank you for that.
Okay, so that's according to the electrical theory. Stars are positively charged and planets are negatively charged. The thing is, it's actually a little bit more complicated than that, because the solar wind has positive and negative charges, the charges that the Earth has can be shielded in some ways. So it's a lot more complicated than that. But overall, this is what we have: is stars are mainly positively charged and planets are mainly negatively charged. So, but going back to the CMEs, stars have fusion reactions on this surface. They have this dramatic flow of gas on this surface. They have very high currents on this surface that causes arc discharges on this surface. And the plasma gets extremely hot. So we know the sun is at a temperature of 5,700 Kelvin on its surface. Now the Earth has a temperature similar to that, but it deep in its interior at the core. The surface of the Earth is at a much lower temperature, as you know. So it's at 300 Kelvin, which is much, much lower. So there's no way that the Earth can have CMEs. It doesn't have hot ionized plasma like stars do. And what happens on the surface of the sun, the plasma gets so hot to the extent that you start having fusion reactions. And it gets usually hotter on the plasma loops. That's why plasma loops are usually so bright. And the plasma loops rise up into the corona, and they're extremely hot, and they heat up the corona of the sun. So that's a possible explanation of why the corona is hotter than the Earth's, than the solar surface. All right, so I guess I will need to explain the calculation.
Well, yeah, before you start explaining your calculations, ladies and gentlemen, I just want to throw this in there. The last report that the doctor put forth and allowed us to see, she was using a lot of mathematics that are far beyond my knowledge. However, no sooner than the live stream was over, the other factions that are out there, the government factions that hire these trolls, were immediately out there trying to debunk her math. They were basically stating that all of her math was wrong, and it was some type of old mathematics. Well, I've never heard of such a thing as old mathematics, but the bottom line is the lady that you're listening to now holds 5 degrees, 5 collegiate degrees, a doctorate, a PhD, a master's in physics. and she is also a professor and lectures in physics every single day at a major university. So if you're going to listen to some little trolls over in the UK that can't even pronounce the words or even define the mathematics, well, Chris, am I correct in saying that we just have to laugh at these fools?
Absolutely.
I mean, I want to bust out. I want to bust out in laughter right now. I want to bust out and laugh so bad at them making complete, utter fools of themselves when they can't even pronounce some of the words that were on the screen in black and white. I want to also clear something up that the doctor in that report from a few days ago, she was not saying that this object was going to be racing towards us in a period of 27 days. She did not say that at all. Well, Doc, you want to go ahead and reiterate what you mentioned about hours?
I use the fact that these objects seem to have a period of rotation of 27 hours. So that's what I use to find the angular frequency. But now I just want to say something. In a way, it is true. The mathematics that I use are old mathematics. They've been around a long time. And I should explain how I usually deal with these things. We are dealing with something that's happening in the solar system that's actually changing our theories of what causes stars to collapse, what causes stars to form. Our ideas have been thrown completely off what we are taught at university. So I have come to the conclusion that most of the theories that we are taught, the most advanced theories, where computer models are used, are based on things that are not true, and they will not give us very good results. Also, I wanted to come up with a simple model and perhaps use mathematics that to me haven't been debunked so much by, let's say, by what is actually happening in the solar system. I mean, I could go into the gravitational theory. I could come up with the fluid dynamics equations for how these objects are behaving, and put them together, come up with a model like people are doing now. But these objects are not actually doing what the theories say they should be doing. So basically, I thought, let's go back to the basic mathematics from the 20th century. Let's see what they can tell us. There is nothing wrong with doing that.
Good explanation.
Yeah, you know, and I want to apologize right off the bat for, well, you know, maybe putting you on the spot for that, but you shouldn't have to clarify or defend yourself on the mathematics that you were using, because cut and dry, I don't think there's any one of these other people in these other factions that are hired by the government. I don't think that they could even begin to decipher your mathematics, let alone by using the fingers on their little troll paws count to 10. So
they're not going to debunk this math.
Yeah.
They're never going to attempt it. And anything that they would do would be extremely rudimentary. And just like the doctor was mentioning, okay, fine, we'll go ahead and use some 21st century math. Boom. Now what are you going to say? Right? There's got to be an excuse for every single step of the way that we go. And I don't see anybody with math, period, the end of story.
Yes. Yes, you see, the 21st century mathematics say there are big problems with them because it's so entranced with the mathematics and the models and how good they look and how complicated it is. For example, the most advanced mathematics I've come across is in string theory. I haven't, my research was not in string theory, but I have, you know, I've come in contact with a lot of string theory. But the mathematics you use in string theory, it's beautiful. You come up with beautiful results, but your results cannot be compared with any observations. So how do you know that your results are good? All you're doing is comparing someone's results with someone else's results. You're adding 5 dimensions. You're working from 11 dimensions to 22 dimensions. someone might try to use some more dimensions. That's what's happening in string theory. This is what's happening in a lot of these models. People are in love with the mathematics and the computer model itself, rather than looking at the observations and making deductions. And this is what I have tried to do. I've tried to make deductions. And I will continue to use simple mathematics if I can, and see where they lead me to. There may come a time where I may consider doing a computer model. But if the simple mathematics are giving us results that are significant and make sense, why do we need to go into string theory mathematics? There is no need. In fact, it's counterproductive.
And we'll probably,
and that is my philosophy.
We'll probably come up with the wrong answer using, using these alternative mathematics for the so-called 21st century. And, just to make something very clear, ladies and gentlemen, whenever the doctor's referring to these models and these computer animations, and the bottom line is you're dealing with a computer, you're dealing with numbers. So whatever information you put into that computer-aided or computer animated model, well, that's what's going to come out. So it's like the old saying goes, a computer can only give you the information that you're putting into it. So if you're skewing the information or you're putting the wrong data in, well, you're going to get the wrong answer, bottom line. And I think that,
yes.
With her using the basic mathematics that even, again, I don't understand. That's why she is here. Using these basic mathematics is giving us potential answers. And yes, everything might not be 150% correct. But again, the bottom line is, do you see anybody else putting their career and their reputation on the line to step up to the plate and deliver this information to you, the public, the world population? And let me add something else here also. The doctor has not put these reports together for peer review. Now, these other factions are squawking like little chickens with their heads cut off because she has not published all of these papers. And now there are over 105, 106 of these reports. She is not interested in publicizing or publishing these reports for her peers to view, because it would probably take them months and months to come up with their own theories. Because I have never seen two physicists or even two scientists agree on something. It's not within their mentality or their personality. Am I right, doctor? I mean, they
yes.
just clash with each other.
Yes, I would definitely clash with my colleagues because I've had months now of looking at these things and developing my understanding of what's going on. And in the beginning, as I've explained before, it's difficult to accept that there are these objects around the sun. In the beginning, you tell yourself, no, it's not possible. And if I start talking to my colleagues, and I've talked to some of them already, they will either say, no, I don't want to talk about this, or, they look at me like, but that's not possible. Because we've been taught theories, and we get to the point where the theories become our reality. It becomes our reality. This is what we believe. It's the theories. So when we see observations that go against the theory, we think, I just didn't see that. But it's impossible. So this is what happens when I try to talk to other physicists who haven't gone through the months that I have gone through observing these things. But I started out by just observing the sky and saying this is not normal. There's something going on. And considering the fact that there may be another star above the sun as the sun sets, that's red, and that's what's causing the sky to look so red at sunset. But when I thought about that, I thought, but how is that possible? But that was enough to start me investigating. But now most of the physicists and astronomers have not gone through that experience, although I know that most of them know that, most astronomers know there's something going on. Because the moment you start talking to them, they're almost afraid. So I know they've heard something. I know there are rumors going around in the astronomy, in the astronomy field that there's something going on. I get a distinct feeling from talking to them, but they don't want to get involved because they just don't want their careers destroyed, or things like that. They want to carry on doing their own research, which is it's all about the Big Bang and, you know, things like that, about a certain galaxy somewhere, or even brown dwarfs in a certain section of our galaxy. And that's safe research. It gets you published, and that's what they need to do, and that's the way they see it.
You know, this kind of reminds me of the whole Bigfoot and Sasquatch stories that have been, you know, they've emanated throughout history for hundreds and hundreds and hundreds of years. But when you put the modern day scientist against the evidence based on what they, you know, based on their own thoughts and what they've been taught, they all sit there and they say, well, that is kind of impossible for a creature of that size to inhabit the area of Northern California, Canada, different parts of the United States, different parts of the world. And they just sit there and they lie to you and they say, it's impossible. It's impossible. Okay. Well, if it's impossible, then where is your evidence that it is impossible? Because it is overwhelming evidence that this creature, many of them, they're pretty much family oriented, and they are living on our planet. They are inhabiting this planet with us. I truly believe in Bigfoot and Sasquatch. I truly believe in alien life, and I truly believe that our governments around the world have been in contact with aliens for many, many, many years. We're using their technology now. And to sit back and state that the information that we're looking at right now, which is overwhelming evidence that I myself and Chris have produced over me, of course, I mean, over the course of the last year, we've produced a ton of information with the help of people all over the world. So what are the odds, if you're going to deal with probability, what are the odds that people around the world are seeing the same thing? Now that reverts right back to what I just said about UFOs. How is it possible that people all over the world, dating back all the way to biblical times, how is it possible that people all over the world are seeing this Bigfoot creature or Sasquatch or the abominable snowman? How is it possible? Is just the entire world blacked out and crazy? Or are we truly looking at real phenomenons? These are actually true events that are occurring. And ladies and gentlemen, you know, what we're dealing with now, it's not a game. We don't have any real way of protecting ourselves from the possibilities of what is out there. The only thing that we can do is try to understand it and try to calculate it. So if you're on the other side of the fence and you're trying to debunk what we've investigated for many, many years, and people before us started to investigate this, very, very credible people. And over the course of the last 35 years of this object being discovered and moving quickly into our solar system, throughout our solar system, there have been over 126 people that have lost their lives mysteriously. Now, how do you account for that? How do you account for these people losing their lives because they were deep in these investigations and they felt they needed to disclose it? And when they were going to disclose it at these very early stages, they lost their lives. And the same has applied for people in the UFO community. You know, going back 20 years ago, if you had solid evidence of UFOs and you were going to go ahead and divulge that information, boy, you better watch your back. And there have been countless UFO investigators who've disappeared, lost their lives mysteriously. And the same applies for the same subject that we're dealing with right now.
Yes.
And we're not trying to sell books or anything of that nature. We're trying to inform the world population, and our backs are against the wall. We have factions out there that are just at us tooth and nail every single day. In the course of a day, ladies and gentlemen, I get multiple death threats. They've actually increased over the past week. Now, yesterday, I received death threats all hours of the day, all through the night. And there's nothing I can do about it. I don't feel that any of them are going to act on it. We have ridiculous idiots out there making videos trying to debunk this information. But like I've said, don't you think that your energy would be better off trying to really look at the information and look at what is happening around the world? It's not a joke. It's not a game. This is real life. And, you know, it has me at some points in time very scared because I don't know what is truly going to happen. And that's why when the doctor brings her reports and uses her time, her effort, and her knowledge to bring her observations to us, it's time to pay attention, because now this is beginning to be way more than some little picture show in a YouTube video. You're now gaining solid scientific proof. And on top of that, we are now seeing very credible photographs that are being captured by the International Space Station. And they're going, you know, they're going to try to stop that information. I mean, I was just told the other day that they just brought back more astronauts. I mean, I don't know if that's true, but I wouldn't want to be up in that tin can right now with all of the radiation in space. I would not want to be in that International Space Station right now, especially looking out a porthole window and seeing that type of object. I'd probably pass out with fear.
Yeah.
But doctor, I wanted to go over this last portion of your report, the one that's up on the screen now.
Yes.
And,
okay. So I'll explain. So I calculated the number of days between October 14th, 2016 and March 14th, 2017, and that was 151 days. Now, if the brown dwarf star was coming in a straight line, as the Earth would go around, every 6 months there would be an alignment, and that alignment and the time period between alignments would then be 182.5 days, because that's a half of 365 days, which is a year. So the time difference between 182.5 days and 151 days is 32.5 days. So that means that the object moved between the two alignments and by an angle which equivalent to 32.5 days of the full Earth's orbit. So from that, I can calculate the angular displacement of the object. So by how much its angular position changed. And that is then 32.5 days divided by 365 days times 2 pi. So we can have it in radians, which I think I explained the last time what radians are. It's a measure of, it's a unit of measurement of angles, which is useful because then I'm going to calculate the angular speed from that. So from that calculation, I get 0.5595 radians. Then once I have those radians, I can calculate the angular speed. Remember, the angular speed or angular velocity is the same as angular frequency. It gives you the rate at which the object is making its orbits. So the angular speed here is the angular displacement in radians divided by the time period. So that's 0.5595 radians divided by 151 days. I don't bother calculating it because I just use it in that form later on. So we can scroll down a bit. Okay, so then I calculate the period, because here I'm going to need the period. And the period is just 2 pi divided by omega. So it's that omega that was in equation 2. I just multiply everything out and I get the period is 1.696 times 10 to the 3 days. And I put that in seconds. It's 8.55 times 10 to the 7 seconds. So I need it in seconds because seconds is the standard unit. And then what we do is we use Kepler's third law. And the assumption is made that the object is orbiting around the sun. So the object is obviously being influenced by the sun, so its trajectory is curving so that it's basically is going into orbit around the sun. It's not quite in orbit around the sun yet, but so this is an approximation. But it's a pretty good approximation, I think, because what we had before of 6.9 AU, I think some other people got it. I think Terrell also had it between Jupiter and Saturn, and he used other methods.
Yep.
So
yours. Go ahead.
So I use the so this uses basically the same method. I basically use Kepler's third law again to calculate where the object is by calculating its orbital radius from the sun. I obtain in this case, and that's equation 4. That's the equation. And A, it's the orbital radius. And I obtain 1.9 AU. Now that is a very interesting result because it means the object is now much closer. Remember, the last time I calculated it, in October 2016, it was at 6.9 AU. Now it's at 1.9 AU. And that is just outside of Mars orbit because Mars orbital radius is 1.5 AU. So this is only 0.4 AU away from the Mars orbit. And remember, this is its position on March 14th, 2017. So that's not its position right now. But the fact that the object moved 5 AU between October 14th, 2016 and March 14th, 2017, and that is assuming this is the same object, okay, if it is the same object, it's moved 5 AU, and that means that it's accelerated, and it's now moving very fast. Now, we do expect objects, as they come in from outside the solar system, to accelerate as they get closer and closer to the sun. They're coming towards what's called perihelion, and that is the closest point to the sun, and they accelerate and move faster and faster. And that is explained by Kepler's second law, and it's basically conservation of angular momentum as well. But it means this object is now moving very fast. And so I didn't put it in this document. I just left it like that. But later on, I thought, well, my goodness, this object is moving so fast. So how long would it take to get to the Earth's orbit? Now, remember, I don't mean get to the Earth. It's likely that the Earth will be at the position where this object will cross the Earth's orbit, because the Earth's orbit is very large indeed. So the probability of it being at the wrong place at the wrong time is very small. So, but once it's crossed the Earth's orbit, it will be in the daylight side of Earth. So we would be able to see it in daylight. Whilst it's on the outside of Earth's orbit, we would see it only during the nighttime. So I calculated it using the fact that it moved 5 AU in 151 days. So I can then calculate its velocity. And from that, I calculated how long it would take to move 0.9 AU and so get to the Earth's orbit. And I got 27 days. So that would be 27 days from the 14th of March. And that would mean the 9th of April, that it would have crossed Earth's orbit. Now, I could be off by a few days. Basically, it's about now. It should be crossing Earth's orbit. And then after a little while, if we are able to see it, and if it was that same object that we saw the footage of, I believe that footage was from the April 4th, wasn't it, Scott?
Yes, April 4th.
So then the object would still be in the night side of the Earth because it would be on the outside of Earth's orbit, and very close, very active object. So it could have been this object because on April 4th, it should have been quite close to Earth's orbit. And of course, we can see out for quite a distance at night. It doesn't mean it's right on top of the Earth Although I did write that other document where the SETI images also always show that there's an object very close to the Earth. So this object could be one of these. It could be this object that's always very close to the Earth, or could be the object that's moving in. But since we haven't seen any footage of an object like this before, I am inclined to think that this might be this very highly magnetic brown dwarf that's coming in and is now getting close to the Earth. And it may have crossed Earth's orbit already. And so in a few days, it's possible that someone will catch some footage of it in the daylight side, although it will be more difficult to observe because the sunlight makes it too bright to sometimes see these things. But this is extremely interesting. I think that this object is actually accelerated and is now so close to Earth, or was on March 14th, so close to the Earth's, well, so we were so close to the Mars orbit. And it may be now very close to Earth's orbit. Okay, so that's basically what I have to say about that.
Yeah, that was, once again, you know, very, very overwhelming information. And just to clarify for everyone, when the doctor is referring to this unit of measurement, this AU, astronomical unit, it's equivalent to 93 million miles, which is the distance from the Earth to the Sun. So whenever she was mentioning 1.9 AU, that's approximately 177 million miles from this object to the Sun. And once again, these are approximations. I mean, we don't actually know for a fact because, well, we're not the boys in blue and the European Space Agency. We don't have the equipment that they do. And I'm sure they know exactly where these objects are. And ladies and gentlemen, if you just take a look at what is happening around the world right now, there have been so many other researchers, Planet X researchers, that have stated that as soon as you start to see a major war erupting in the Middle East, basically what they're calling World War III, whenever you see this, it's potentially going to be a false flag. It's supposed to be a major diversion of some kind to keep our attention off of what is really happening. And, you know, I had a very long conversation with Gil Broussard back in December of 2016, and he divulged that information straight to me. He said, listen, Scott, as soon as you see things happening with the country of Israel and Syria, and you start to see the emergence of this World War III in the Middle East, you know that you are very, very close to the arrival. Now, something I want to also talk about very quickly is these other troll factions have come out and made some videos and statements and stating that Gil Broussard said, quoted, that if we did not see Planet X by March of 2017, we would not see it for another 100 years. Well, ladies and gentlemen, I've had contact through another radio show host, and she has Gil's direct cell phone number. I had her call him, and he was very busy at the time, but he was very interested in the statements that were made using his name. And without hesitation, he stated that he never, ever said that. And he was doing an interview on Pastor Paul Begley's YouTube channel on February 4th. And he never mentioned that if we do not see this object in March, that we won't see it again for another 100 years. So just to clarify, if anybody has heard that type of rumor, it's not true. It's absolutely not true. And something else that you have to keep in mind is that there are a lot of unknown factors that we're dealing with. We are the people on the outside looking in. So we don't have the real information on what's really going on with these world governments. You know, one minute the United States is, you know, having issues with China. Next minute they're having issues with Russia. But in fact, ladies and gentlemen, all of these countries are doing business together. It's a fact. You know, just like this supposed bombing that went on at this Syrian Air Force base or airport. Well, ladies and gentlemen, they're already proving that this installation was abandoned and there was nobody there. So once again, these are false flags meant to deter you and point you in other directions, to keep your attention on something else other than what's going on in the skies above. Now, Doctor, and also Chris, any last words before we end our broadcast?
No, sir.
Well, I'd just like to say thank you, Scott, for having me and getting me to explain my article. And it was, and looking at that footage and being able to talk about it, it's just totally fascinating to me. So I feel I'm grateful that someone actually filmed that, because it's amazing for me to watch. It's like all I've been talking about for so long, and now just seeing it there, it's just so amazing for me. So thank you.
Yeah, I'm sure that I could speak for both myself and Chris. We should be the ones thanking you, you know,
Yep.
for putting yourself out there, putting yourself on the line. And, you know, we definitely thank you for utilizing your intelligence and your education and your background. And as of right now, you're the only person on the face of this planet that has the guts and the fortitude to step up and help us. And that's
Thank
very
you.
noble. That's a very noble and respectable thing. And let me add just one more thing. For every single individual out there that is discounting what the doctor is saying, and whether you're making fun of it or you're trying to debunk it, you should be ashamed of yourself, because you are not even human. You don't even belong on this planet anymore. This is a woman that is trying to help out and give back something to humanity. It may not save the planet. It may not save all of humanity, but at least she has the guts and the balls to stand up for what is right. And you, the people in the other factions that try to wreak havoc in this information, you should really, really be ashamed of yourself. And frankly, I don't know how you wake up in the morning and look in the mirror. Chris, any last words?
There's a lot I'd like to say, but I'm going to refrain from now. I was going to talk about a certain investigation, etc., but I've been told not to. So we're just going to leave it at that. But I want to mention thank you tons, Doctor, for coming on, and Scott for hosting.
Absolutely. And ladies and gentlemen, we're going to be looking into some information. The doctor's working on some information. I've got a lot of emails coming in about the Earth's tilt and possibly what degree are we tilting right now. Now, we all know that we have this 23.5 to 25.5 degree tilt, but there is definitely something going on with our planet and this entire climate chaos. We're going to try to get to the bottom of it, and as soon as we have the information put together, we will definitely bring it to you. So most definitely stay in tune with Planet X News and the Nibiru channel and Chris Potter's channel, because you never know in an instant when we're going to come out with some breaking information, and you need to have that information. Also, something I do want to mention is the X Factor radio show that I started a few days ago is fully up and operational, and there are programs on the radio station as we speak. So if you go into the description box of any of the videos, including this live stream, you'll see a direct link for X Factor Radio. Click on the link, go to the station, and click the follow button. Set up your notifications, and you can listen to any of the broadcasts anytime you want. And again, if you have Bluetooth technology with your cell phone and in your vehicle, you can listen to it on your radio. You can listen to it on your television or your computer. You can listen to it at your leisure. So once again, I'd like to thank everyone who was with us today. And once again, keep an eye in the sky and stay tuned. Hello, everybody. Welcome back to Planet X News. It is April 12th, 2017. And once again, we are here with Chris Potter and our physicist. And today, ladies and gentlemen, we feel that we have some pretty groundbreaking information over the course of the last couple of days. All kinds of information has been coming in. We have some pretty spectacular photographs that were captured on the ISS earlier in the week. And now, once again, a photograph was shared with me yesterday, and the photograph was taken yesterday from the ISS, the International Space Station, clearly showing a very large, what seems to be a pinkish or reddish type of planet, or possibly this brown dwarf star. We also have the latest report from our physicist, and she was doing some calculations based on the things that were happening with the magnetosphere. And her calculations are pretty good. Now, it is putting this brown dwarf star, or this major object, very, very close to our planet, very close to the sun. And from what we've been reviewing over the past several hours, it looks like it's coming in rapidly. So we're going to go ahead and get directly into this information. Doctor, how are you today?
I'm fine, thank you, Scott. And how are you?
Oh, I'm doing pretty good. You know, besides everything that's going on in this world right now with the threat of war in the Middle East and nuclear war over there in Korea and everything else going on around the world. Yeah, I'm having a pretty good day. Chris, how about you, buddy? Christopher?
I'm doing well. I'm excited to look at lens flares in space.
Yeah,
talk about mathematical formulas that are just fantastic, right?
Yeah, ladies and gentlemen, what Chris is referring to is naturally any information that our physicist is coming out with, the trolling camps, the other faction, if that's what you want to call it, they are trying to debunk and disprove with dishonesty what is actually occurring. And basically, they're putting out a lot of false information. And for everyone that is subscribed to both of my channels and Chris's channel, well, the bottom line is the doctor has been putting forth a lot of her own individual time and effort into researching and investigating what is actually occurring. Now, ladies and gentlemen, here's the bottom line. And I've said this before, and I'm going to say it again. There is nobody else on this planet that is stepping up to the plate and putting themselves in the limelight and using their knowledge and their credentials to help us out. All we see out there are a bunch of other fakes that are trying to disprove what we are researching and investigating.
And they aren't putting forth, sorry to interrupt you, Scott, they're not putting forth any real math or any real math debunking. If you're going to debunk somebody's mathematical formula, give me the math.
Yeah, I would have to agree. You know, yesterday, one of these factions put out an absolutely ridiculous video. And during the video, they couldn't even pronounce their words correctly. And they were basically turning our doctor's words around and basically just outright lying. And then when it came to the math portion, well, once again, they just made absolutely ridiculous claims that the math was wrong, but yet they said, quote, well, you know what? We're just going to go ahead and skip over the math because it's wrong anyways. Anyhow, anywho, and anyway, that was absolutely ridiculous. And yes, ladies and gentlemen, the death threats keep coming in. Yesterday was a pretty bad day for me in general. I received, I don't even know how many countless death threats by text message, videos being made about me, talking about, well, I'm not even going to go into that. But I don't want to waste any more of your time. We're going to get directly into the information that came through with these photographs. And I'm going to go ahead and bring these photographs up. And this photograph, well, I have to share it first. Let me go back and try that again. And doctor, after I have this photograph up, go ahead and give your commentary.
Okay. Yes, isn't that amazing?
Tell
Now,
us why it's not a lens flare, because that's the first friggin' thing people are going to say. It's a lens flare in space.
Yes, okay. So the brightest object in the image is the light source, and it looks kind of white. Okay, so that's the brightest thing, the thing that looks like the sun. And so if we were to have a lens flare, the brightest object would be the one to create the lens flare. Okay, that's what the lens in the camera would produce a lens flare of. There would be an internal reflection inside the lens, and we'd get a lens flare of the brightest object, which is the object that we think of as the sun. And the sun in this image looks, maybe we could say pale yellow, but basically it's mainly white. So we would expect the lens flare of the sun to be white. And there's no way that the sun can produce a red lens flare, because the sun is not emitting red light, it's emitting white light, or sort of pale yellow light. And what we see there at 3 o'clock is a mainly red object. And you can see that its shape is also very different from the sun. The sun has all kinds of beams coming out from it, or perhaps coming into it. And this object does not have that shape at all. And if it was a lens flare of the sun, then it would have a similar shape, because it would just be a secondary image of the object, which would be the sun. So there's no way that this red object can be a lens flare. It has to be a real object, and it has to either be emitting mainly red light or reflecting red light. If it's reflecting red light and it's a planet, then we'd suppose there's a source of red light around, but it's not the sun. The sun is not emitting red light. So there we are, and it's been circled by somebody, obviously. It's obvious there's something there. Also, notice this object is more in focus than the sun itself. The sun looks very much out of focus, except for the beams coming out of it. So again, how can you have a lens flare that is more in focus than the main image, the primary image? It's not possible.
Let me ask you another question.
Yes.
We're obviously using similar lenses on Earth. There's probably nothing different between the lenses that we use on Earth to take pictures where we get lens flares and the supposed lens flares that are on pictures from the ISS feed, because the camera lens itself is probably not much different than a regular high-grade lens in a telescope or camera, whatever. So along those lines, I was thinking it's possible because of a lens or light anomaly or camera aberration that, well, gosh, that would explain away the quote-unquote lens flare action. However, it doesn't look like we can explain it away that easily this time around.
No, not at all, because, I mean, whatever lens we have in front of this camera, it would affect the main object as well as the lens flare the same way. So the only way you could have a red lens flare is if the main brightest object in the image is red as well. They have to look similar, not the same size, but they have to have similar shapes, and they have to have similar colors. I mean, they could, obviously the brighter one is always the main image, and the less bright one is the lens flare. But here, there's no connection between the two. They have different shapes and they have different colors. So one cannot be a lens flare of the other. They have to be separate objects.
That's a good explanation. I've seen lots of two sun or lens flare pictures where at first I was completely duped that, oh, it's two suns. After a little bit of investigation on my own, a year or so into my YouTube channel, yeah, okay, I am. I'm looking at lens flares. They're pretty obvious at that point. But you made one point that was clear to me right now, is that those flares are typically the exact same shape or the same color. And that I don't see in this picture. And I don't think it really, and for the listener or viewer, it means nothing that it's in space, quote unquote, or the ISS feed. That really doesn't matter, because it's just a camera like we would use on Earth. Maybe there's a couple little things out in space we're not too familiar with that might cause a different lighting or shadowing or whatever other type of aberrations maybe we're not familiar with. But in this case, with the standard explanation that you've given countless times, unfortunately, you've needed to about lens flares, it wouldn't, it doesn't jive. It's not the same. There's obviously something there creating a red, what looks like a green stripe through it.
Yeah,
now, I've been real hesitant.
Like a yellow.
I've been real hesitant to say that, hey, guys, that's not a lens flare. But I'm going to have to say, I don't think it's a lens flare either. I think it is the flying cheese sandwich.
I want to interrupt here very, very quickly. Ladies and gentlemen, you notice this this pixelization around the red circle that was drawn on the photograph just to encircle it. And that is the reason why it is pixelated. I also want to mention something right now before things go a little haywire. We already have trolls in the live chat.
Of course.
They're claiming that this picture was stolen from them. Okay, well, listen, ladies and gentlemen, and to all of the trolls out there, if you by chance don't know anything about copyright law, federal copyright law, well, this is the International Space Station. This is a public feed, and you do not have the legal right to claim any photographs, whether you have taken them or not. This belongs to the federal government, and it cannot be copywritten by anyone. We've already gone over that information back in October, November, and December when troll factions were trying to claim government copywritten video and photographs from the International Space Station, from Soho, Lascaux, SDO, Secchi, and you name it.
Wow.
So please don't even go there. Just get out of my live feed. Go find a job. Go crawl under the rock where you just popped up from. This photograph was sent to me by one of my good friends, and he captured this photograph. He encircled it, and he sent it to me in my Facebook inbox. Okay,
so they were just looking at the ISS feed, saw it, took a snapshot, sent it to you. Boom.
Very simple.
Yeah, that's BS. Yeah, so whatever. Yeah, they need to go away. Go ahead and continue, Scott. You're the man.
Yeah, so getting into this federal copyright situation that these trolls try to use right now, they're trying to get channels kicked off of YouTube very rapidly by filing false claims and flagging YouTube videos and YouTube channels. 48 hours ago, one of my other channels, which strictly deals with Earth weather and space weather, I haven't uploaded a video in weeks onto that channel. I got an email from YouTube stating that they terminated my YouTube channel. It's called Earthwatch and Space Weather. Well, the email stated that it was taken down for gross violations concerning spam and scam.
Oh,
well, that was absolutely ridiculous. So I went ahead and I immediately appealed their decision. And when an actual human being took a look at the information, within 15 minutes, I received an email back from YouTube apologizing for terminating my channel. It was reinstated in 30 minutes, and that was that. So ladies and gentlemen, YouTube uses bot programming, and apparently these trolls think that they are actually onto something to bring your YouTube channel down. But through a course of several